Welcome to every listener this afternoon on our discussion on our physical science paper 1, our physics paper coming up this Friday. I hope that you have a very productive day so far. I'm going to emphasize some key issues and common errors to avoid on each topic. Now, you must remember, each topic has its own laws, own principles and definitions, and those principles and laws leads to formulas and equations. So every question will consist out of a definition that you must be able to formulate, and then you are given a scenario. And that scenario you must solve or explain by means of the principles and the laws, and also using the correct equations to solve that scenario, that problem given. So that is the recipe for each question. Now I'm going to start off with projectile motion, and I'm going to discuss now the key issues and common errors to avoid on these topics, and starting off with vertical projectile motions. And now the first important definition there is on free fall, and it's very important. There are two key words. The word is the motion of an object, very important, and then even more important is the fact that that word only, the gravitational force only. Learners lose marks on those two words. And then if they ask definition of a projectile, remember it's an object, and then upon which the force acts, but again the very important word only. It's the only gravitational force that acts on the object. Now, the next thing, after that you get to your calculations, your scenario given. It's very important to really first study the scenario very, very carefully. Look at the data information given before you decide on a formula. Why do I say so? Because if you have a question of 3 or 4 marks and you choose not the best formula, it will end up in a multiple step calculation, and the chance of losing marks there are very big. So choose the correct formula so that you can calculate a 3 or 4 mark calculation with a single step calculation. So before you start off, make sure that you identify the most effective formula. The formulas are on the data sheet, so please use your data sheet. Then the next very important thing on vertical projectile motion is to make sure that you award correct direction, correct signs to your vector quantities. You can have the correct formula, you can substitute the correct values, but at the end, if your sign allocation is wrong, then you will end up with 1 out of 4 or 1 out of 3, just a mark for your equation, and you lose your substitution mark because of a wrong sign, a positive sign where it's supposed to be a negative sign, etc. So make sure that you award signs, say upwards positive and all vectors downwards negative. So looking maybe at an example, if you are throwing a stone upwards, remember that gravitational acceleration stays 9,8 downwards. It doesn't matter if the projectile is moving upwards or downwards, or it is at its fulcrum, at its turning point. Gravitational acceleration is always downwards and with a value of 9.8. So say for instance we throw a ball upwards, then you will see VI is positive, and delta Y, the displacement, is also upwards positive. So clearly now I've chosen upwards as positive. So then remember G will be negative 9.8. And then you will be sure you will get your marks. Just on rounding, remember at least 2 decimals. You can round off to more than 2, but the rounding off must be correct. So round off 2 decimals at least, and then lastly again, use your data sheet. Now going to graphs on projectile motion. Now graphs can be very challenging, and especially in the last few years they have make use of a scenario where more than one object is being thrown up. So object B and C, for instance, in this graph. And now a velocity time graph will always be a straight line graph with a gradient or without a gradient, but in vertical projectile motion it will have a gradient, and very important, the value of that gradient must be always 9.8 in magnitude. So if 2 balls is being thrown upwards or downwards, very important, you will see the gradient of both objects must be parallel to each other because the acceleration is the same. Then I'm going to go to a scenario that was given in the previous NSC exam, and that is where 2 balls was thrown upwards, B and C. Now the learners really have big problems with this kind of question. The important thing is to realize if 2 objects is moving, then there must be, you are forced to use simultaneous equations. But now the question is, what is that quantity that is the same for both object B and C? And the answer is that the position of B and C at the stage is the same. And therefore, there lies the key to solving this problem. So you must get, indicating in this graph with the asterisk, YC equals YB. So that's a position where the ball B and C meet each other. So that is the key for the simultaneous equations to solve the problem. Now, what must you get? You must make use of the formula for delta Y. And you must get a formula for C, and you must get a delta Y formula for B, object B. Now, I haven't written the complete formula. You know it will be delta Y is equal to VI delta T plus half G delta T squared. But the important part is here, the delta Y for C. Remember, change in position is always the final position, in this instance YC, and then the initial position. The initial position, if you look at the diagram above, the initial position was 30 meters above the ground level. So our reference point is a ground level. Therefore, delta YC is YC minus 30. For YB, the final position is again YB, but the initial position is 0. It was thrown from the ground. And now immediately you will see, you have this term YC, this position YC and YB. And now you can manipulate these 2 equations to state YC equals YB, and then from there on substitute your values and solve the problem. So I think that's very important to remember when working with 2 objects moving at the same time. And this is really a level 4 question, and I hope really if you get hold of such a question in the paper, you will be able to solve it. Then just reminding you, every position time graph, a vertical projectile motion, must be a curve. A curve with a positive gradient that is increasing, or a curve with a negative gradient that is also increasing, decreasing in a negative way. But that is on vertical projectile motion. Then moving on to the next important topic, and that is normally vertical projectile motion is normally question 2 in your question paper. Then moving to the question about momentum and impulse. And momentum and impulse will always, or most of the times, be question 4. Now, what is the first definition that you must be able to define? Now, the two important keywords that learners often omit, and remember, it is common errors that I want to emphasize. Learners many times just say the momentum before collision. Very important is the total momentum before collision. And I know we work with linear movement and linear collisions, but you don't have to say the total linear momentum. It's not wrong to say it, but you can also, this conservation momentum applies for all kinds of collisions, so you can just say the total momentum before collision in an isolated system remains constant, or the total momentum before collision equals the total momentum after collision. But the keywords, the total momentum before and after, and then it must be in an isolated system. Now, speaking of isolated system, very important, the definition of isolated system can also be asked. So remember, it is the net external forces is zero. In an isolated system, the net external forces, you can't just say the external forces is zero, the net external forces is zero. So, and it's not only that there's no external forces. That is a half definition of isolated system. It is the net external forces is zero. Then, many a time incomplete formulas when using the principle of conservation of momentum to solve problems. Learners, a lot of times, have incomplete formulas. They state E before equals E after, and then they use literally a E and not a sigma sign. And they don't indicate momentum, they just say E before equals E after. That is a wrong formula. Or they use a more proper formula, MA times VA plus MB times VB equals etc. But now they omit the initial or the before. MA, VA, before or initial, etc. And then equals, and then on the right hand side indicate that it is final or after collision. That is also incomplete formula. Third incomplete formula, you just write down P before or P initial equals P after. Again, that is the total momentum. So it is the correct formula. It is the sum, that sigma sign, the sum of the momentum before or the initial momentum equals the sum of the momentum after or the final momentum. That's a correct formula, and I will really advise you to start off with this version of the formula. The chance of mistakes are very little, so start off with them. Then you can elaborate on object A and object D before and after collision. Right, this question is also always about two objects. Then, there's a tendency for some learners to use this formula to calculate a scenario about the conservation of momentum. No, that is a total valid formula. But the problem is that the learners don't really understand this equation, so they substitute it wrongly into this equation, but also they write down the version, later on I indicated, delta PA equals delta PB, and not delta PA equals negative delta PB. The change in momentum of A is equal to negative the change of momentum of object PB. Now this formula is related to Newton's third law, FA equals minus FB. But the problem is, the learners don't understand it and they omit the negative sign. And then immediately, unfortunately, it's a wrong formula and you will lose your marks. So if you use that formula, please be alert on that. Then, when only moving to impulse. Impulse is when you're only dealing with one object. And you will see in your formula for impulse that F net equals M and then the change in velocity. So you see there's only one mass. It's only about one object in the collision, and that is equal then to the change in momentum. Remember, the unit for impulse can be Newton seconds or kilogram meters per second. Both units are accepted for impulse. Remember, impulse is a vector, so you must award a direction at the end, and remember that your velocities, v final and v initial, if a ball bounces from a wall, the direction of v final and v initial is different, so they will have different signs. So please award signs to your velocity, and remember then your final answer for momentum or impulse must have a direction. If they just ask the magnitude, then you can omit direction, but otherwise please remember east, west, or to the right or left, the direction must be indicated. Then we are moving to our third topic, and that is moving to Coulomb's law and electric fields. Now, again, we start off with our definition and common mistakes in our definition. Now, the word product is many a times omitted. And secondly, learners, they think about Newton's gravitational law, and then they mistakenly, instead of charges, they include the term masses. And remember, this is the product of the charges and not the product of the masses. And then secondly, the safest way to end off the last part is to state that the electrostatic force is inversely proportional to the square of the distance between their centers. If you use this term square of the distance between their centers, then you are safe. Either if it's a sphere or a particle, it is both accepted that you can use the term the square between their centers for either a sphere or a particle. Then on our field patterns, you can be asked to draw a field pattern for two opposite charge objects or two same charge objects or for a single charge. Remember that your field pattern must have an accurate shape. The examiners are nowadays really very strict on the shape. If there are curved lines in your shape, make sure the direction of that curved lines and it must be accurate and it mustn't have a more or a less shape. Make sure that the shape is correct, that your field lines touch the sphere, and then that the direction must be correct from positive to negative. You can't lose marks on such a question. Then the next principle regarding Coulomb's law is a principle that you have studied in grade 10, and that is the principle of conservation of charges. And the principle is plainly that the total charge before touching and the total charge after touching is the same if it is an isolated system. So now, how do you apply this in a question given to you about spheres before the time have a certain charge and then they touch, and then you must calculate now the net charge on each of the spheres. If there are 3 spheres before the time, firstly you add the charge of the 3 spheres. Then you touch. So if you then remove them from each other, then you must divide it by 3, because there's 3 charges now, each with their own charge, and you divide the sum of charges by 3. And remember always, after touching, the spheres will always have the same charge, or they all will be positive, or they all will be negative, and the magnitude of the charge on each sphere will be the same, because we are working with identical spheres. So that must be the same in magnitude and in type of charge after separating the charges from the spheres from each other. Then you can be asked to calculate F net. Now there are two scenarios. The first scenario I'm going to look at is a scenario where the three charges are at right angles. Q1, Q2 and Q3. Now you must use Coulomb's law to calculate the force of Q1 on Q2 and then of Q3 on Q1. Because the question is now, what is the net force on Q1? So you have two calculations using Coulomb's law. But now the very important next step is, you must now draw a vector diagram indicating the direction of charge, the force of charge 3 on charge 1 and the force of charge 2 on 1. So you must have a force diagram. Why do you have to have a force diagram? Because secondly, you must be able to draw a vector triangle. And the vector triangle are crucial because the charges are rectangular to each other. You must use Pythagoras and sine, cosine and functions to calculate whatever is asked. You are going to need to apply Pythagoras principle to a vector triangle, say for instance to calculate F net. Or you can be asked to calculate the direction of F net, and then you must use sine or cosine functions. So it's very important, if the spheres are at right angles, you must have a vector diagram to draw a vector triangle to really calculate F net by using Pythagoras, etc. Then you can also be asked to calculate F net if the charges are in a straight line. And then there's another very important thing. If you are given Q1, Q2 and Q3 and you are asked to calculate the net charge on Q2, now the first step again is to draw a vector diagram of the forces acting on Q2. Why? Because you must know if the two forces are working in opposite direction on Q2 or in the same direction on Q2. So in this instance, I've indicated here, say the force of F1 on 2 is to the left and the force of F3 on charge 2 is to the right. Now you clearly realize that to get F net, you must subtract the values calculated by Coulomb's law for F12 and F32. So then you subtract it and you get the answer. The next thing I must emphasize, please don't substitute negative values into Coulomb's law. Negative values for charges. The definition says it's a product, the product of the magnitude of the charges. So you mustn't substitute, say for instance, -3 times 10 to the power -9. Only the magnitude of the values, because the negative sign can put you really on the wrong track. And if your answer is negative, you are going to derive something from that answer, and you can't derive nothing from the fact that you get a negative value for F. And it is wrong. No substitution of negative charges values into Coulomb's law. It is the vector diagram that determines what you must do to get F net, if you must subtract or if you must add it. And on the next page, I just repeat the importance that the vector diagram determines what you must do with the two forces to get to the answer. Remember, interpret your answer. If they ask the net force, you must now then at the end say, if you subtract the two values from each other, and then to the left was negative, and now your answer is negative, then you must state, therefore, such Newton to the left. So interpret your answer if they ask just F net and not the magnitude of F net. If they ask the magnitude of F net, it is not necessary to have interpret the direction. Then moving on to electric fields. Now, the definition for electric field at the point always causes some trouble. The definition of electric field at a point, and that's the important part, at a point is derived from the formula E equals F divided by Q. Now, the key words in the definition is the words, the force, and then very important, per unit positive charge. You see here are some very key words. That word per unit charge is very important. And it's a positive charge. Normally, in a definition, they subtract 1 mark for each word, key word omitted. Now, if you omit per unit or positive, you lose already 2 marks and 0 marks for definition. So remember the keywords, force per unit charge. The moment that a marker examiner sees the word area and electric field at the point is asked, he knows you are defining the principle of a description of what an electric field means, the general definition or description of electric field, namely that is the area where a charge experiences a force. And that is a quite total another definition. If they ask, define or describe what an electric field is, yes, then you say it's an area where a charge experiences a force. But that is a different definition to define electric field at a point. Right, then also, here you can also be asked to calculate E net. And I want to ask you, please, read carefully. Read if they ask F net or E net. For Coulomb's law, it is F net equals. If electric charges, a scenario about electric charges and the net electric field are asked, it is E net. So if you write down at such a question, F net equals something, and even if it's a correct formula, it's a wrong formula. So make sure if they ask F net or E net. Now, they can only ask a question about E net for charges in a straight line. Charges at a certain point in a straight lines. In a straight line, they can't ask it in a rectangular shape, 90 degrees to each other. So only in a straight line. Now the principle is the same. First, draw a vector diagram for the force, for the electric field acting through point P and due to Q1, and the electric field acting through point P due to Q2. So you must have a vector diagram. E1, the electric field due to Q1, E1 to the left, and E2 through point P to the right. So now, what do you know? You know now that to get E net, you must subtract the 2 values you have calculated. Now, what is the formula that you use? It is EKQ over R squared. So you have 2 calculations using that formula EKQ over R squared. You get the 2 answers and you subtract the values from each other, and then you interpret your direction. Then if your answer is negative, in this instance E1 in my example was to the left, and that if I've chosen it as negative, so if the answer is negative, then my direction at the end will be to the left. So interpret your answer according to the value you get. Now again, I've really highlighted it. Also here, no negative values substituted for Q into the formula A KQ over R squared. It's the magnitude of the charge and not if it is a positive or a negative charge. You use a force diagram to indicate the direction and the final answer. No negative values must be substituted for Q. in any of these two. Now, on the next page, I've just reiterate very clearly, no negative values, draw a vector diagram, and then lastly, interpret your direction in your final answer. You must interpret your direction. Remember, sometimes they ask a question where you need the charge of an electron or even the mass of an electron. Remember, that data is on your data sheet. So don't forget that information about electrons is on your data sheet. Then I'm moving on to our next topic, and this is now electrical circuits. Also a very important topic, quite a few marks. And what is that you must remember? Again, we start off with our definitions, and Ohm's law is one of those. Remember, Ohm's law has nothing to do with resistance. It's a relationship between V and I at constant temperature. It does not include the relationship of V and I with R. Many times learners just use the formula for Ohm's law, R equals V or I, and they try to translate that to Ohm's law. No, Ohm's law is just about V directly proportional to I at constant temperature. And then the definition of EMF, very important. The two crucial words, keywords, it's a maximum energy per Coulomb charge, or per unit charge. The maximum energy per Coulomb or unit charge. That's a crucial word. If I ask the EMF to define what is an EMF of 12 volt, now you just say it is 12 joules energy that can be provided per Coulomb charge by the battery. Now, what is not acceptable? Not acceptable is to state that the EMF is a potential difference across the poles of a battery in an open circuit or if no current is flowing. That is not a definition for EMF. It is 0 marks. This is the method how you can determine the EMF of a battery. It is not the definition. Now, just quickly referring to the formulas, I'm just going to go very quickly through it. The formula for current, I equals Q over delta T is on the data sheet. The equation for potential difference, V equals V over Q. Potential difference of the resistance formula, V over I. And then make sure that you know for series resistors, for series circuits, that you know these three basic principles. The current is the same, the resistance you add, and the potential difference you also add together to get the total resistance. For parallel resistors, no, it is current dividers. You add up the different branches to get the total current, but very, very important, the potential difference is the same across all parallel branches, and then also the formula calculating the parallel resistance. I know there's an alternative formula that's not on the data sheet. We refer to it as a product sum formula. Make sure that maybe if you want to use that, you know it. It's not on the data sheet, but remember that only apply for that product sum formula, only apply for 2 resistors in parallel. You can't use it for more than 2 resistors in parallel. Right, now remember, if we are working with parallel circuits, remember the addition of parallel resistors always decreases the total resistance. And then secondly, the moment internal resistance is present, then Ohm's law of V equals IR is rewritten in this formula. EMF equals I times R plus I times Ri, the internal resistance. Now, you can also be given data about a device, the power of a device given to you, and then normally we're not used to maybe have in an electric circuit given information about the power of the device, but it isn't mustn't be a problem to you. You just go to your power formulas and derive either the voltage or the current, etc., derive it from that power value. So don't be disturbed if they, in a normal circuit diagram, are referring to power values. Then you just use on your data sheet your formulas for power. Right. The last thing about power, remember that power relates to brightness of a bulb. And therefore, if there is a question about power, they will normally include can include a bulb. And then remember, if the power increases, the brightness of the bulb will increases, and vice versa. So that power relates to brightness of, for instance, a bulb. Then internal resistance, just coming back to that. Now, internal resistance causes V lost, and I like the term V lost. So V lost equals the current times the internal resistance, Ri. Now remember, you can, if you change the circumstances the conditions in a circuit, that changes the current I. Remember, VI will immediately change. And if VI changes, V external will change. So you are, I think, now used to questions about this, where they, for instance, they add a resistor in parallel, which causes the total resistance to decrease, or they take away a resistor in parallel and then the resistance increase, or they open a switch or they close a switch, and now they ask what will happen to the voltmeter reading and voltmeter reading as in this circuit diagram. Indicate the total external resistance of the circuit or across the battery. So normally, in such a question, if they tells you they add a resistor in parallel, the way you answer it, immediately you relate to what will happen to the total resistance in the circuit. And in this instance, it will decrease. Then you must relate to the total current in the circuit. And that will increase if total current decreases. And then also, very important, you relate it to V lost. So if total current increase, then V lost must also increase. And now you will realize there is less voltage available for the external circuit. So therefore, V external will decrease. And then also it can relate to the power that will decrease and the brightness of some bulbs that will decrease. Now just the term short circuit. And I have really seen in the last 2 or 3 papers, in 2 of those papers, there was something about the term short circuit, and they have short-circuited a circuit with a wire. The last paper, they short-circuited with a wire. Now, what is short circuit? It is exactly what the term says. You cut out a certain part of the circuit, but the result is always of a short circuit that the total resistance decreases. Now, if the total resistance decreases, you will know that the total current increases. And it's that total current that increases that will cause the damage, that will cause overheating. So short circuit means you cut out a part of a circuit. It can be an accident, or it can be deliberately with a wire. You breach some resistors, and then you lower your resistance and you increase your current, and that is normally not a good thing for a circuit because you can have some overheating, some damage. Then, lastly, moving to graphs on internal resistance. And I know you have an experiment. One of the experiments is on internal resistance, and therefore, this topic of internal resistance is a way in which examiners can bring in a question about some practical stuff, you know. Now, for example, in this graph of resistance against a current, 1 over current. It's a straight line. So immediately, if it's a straight line, you must realize that you must relate this formula of EMF equals IR plus I times internal resistance. You must be able to relate this to a formula for a straight line. So for this given graph, you will agree with me, I can state that R is directly proportional to 1 over I. That is what this straight line graph tells me. Now, if I want to change it into equation, I must have the value of the gradient added to this formula. And in this instance, you will realize, and I will just move on the PowerPoint, you will realize that the gradient is R over 1 over I, and that is equal to Ri, and it is a voltage value, so the gradient indicates the EMF. Now, you can say R equals the EMF, which is the gradient, divided by I, and then you will see you have a y-intercept, and your y-intercept have a minus value, and that minus value is the value of the internal resistance of the battery, and the gradient indicates the EMF. Now, what's very important, you must, after you has transformed your formula to a straight line formula, you used the y equals mx plus c straight line formula, and then you use the y and x values on your graph. You use the y-intercept, you use the gradient. At the end, in this final formula, all the components of your formula for EMF, the EMF, sorry, now I moved on, the EMF, the resistance, total resistance, the EMF, the internal resistance, must be included in that final formula for your straight line graph. This is also level 4 questions. But if you stick to that, transform your formula into a straight line formula using the y and x values of your graph, although it's a level 4 question, it is solvable. And now your y-intercept, what does your y-intercept tells you, and what does your gradient tells you? That is 2 crucial parts that you must be able to identify. Right. The last graph on internal resistance is also one that we have in the previous paper has got, and this is actually also from your experiment where you decreases your V external by increasing your current. Say for instance you add resistance in parallel, now your current increases, and as your current increases, you see that there is a drop in voltage. There's a drop in voltage. Now immediately that word drop in voltage must indicate to you that this must be something about lost volts. But the first thing that you can determine from this graph is the EMF. At current 0, that is indicating the EMF at current 0. The voltmeter reading at current 0 is the EMF. So immediately you can derive from this graph that the EMF is 1,5 volts. Secondly, the gradient is the loss in volts, the decreasing in the potential difference divided by I. So immediately V loss divided by I, so the gradient indicate the internal resistance of the battery. Remember, graphs are very important. The interpretation of graphs is many a times a big problem. So make sure in these topics, like that electric circuits, and especially including internal resistance, that is a potential question for the exam. That concludes our electric circuits, and then we move on to electrodynamics and few important principles at electrodynamics, and I will go quickly through this. Remember, there's an advantage at alternating current. Alternating current is to our advantage to help us to transfer electrical energy over very big distances, and you are able to step up and step down. It was previously asked maybe a long time ago, but the advantage is you can also step up and step down your voltage. Now, you have on your data sheet a lot of formulas for alternating current, and I've shown it here. And you will see very important alternating current. We are not working with direct current. So the subscripts, please, it is on your data sheet. So remember to include the subscripts. You will lose a mark if you omit the subscripts. In general, just be reminded that there's a mark formula, and then remember, an answer must be accompanied by a unit, and if there is direction, there is an extra mark on the direction. Again here, and I'm going to state it very shortly, choose the best formula. Don't change a single step calculation into a multi-step calculation, because you have start off with not the best formula to solve that problem. Right. Make sure that you know the definition of RMS voltage. It is a difficult definition. Don't get confused, so spend time with it. It is a DC. The AC RMS value is a DC potential difference that dissipates the same amount of energy as the AC. Now, rated values. Quickly on rated values. I've seen in the previous NSC grade 12 exam, the whole question about rated values is maybe something that must be highlighted. Quickly, I refer to this circuit diagram, Y and Z. Now, say for instance, you were able to calculate, you see it is a series circuit, so the 220 volts are divided between Y and Z. Now, Z only receives 40 volt. But the question they ask you, you must get the rating, the power rating of resistor Z. It is given as X watt, and the rating, the rating of the VRMS is 220. Now, if you use this value, say 40 volt, to calculate the resistance of R, because to get the rating of that resistor, the power rating, you must get resistance. So you say, for instance, you have all the values and you are able to calculate the Z, say, as 80 ohms. Now you must get the power rating. You can't use the 40 volt. Say, for instance, P equals V square RMS over R. You can't use the 40 volt, square the 40 volt, because to get a rated value, you must get the rated RMS value. So you must use a 220 volt to calculate the power rating and not the 40 volt. Please remember that. And a multi-plug, and question maybe if they say more plugs is added, remember at AC circuits there's no internal resistance. But if you add devices to a multi-plug, the resistance R total will decrease, IT will increase, and you will get overheating. Right, just quickly on generators, remember the principle is electromagnetic induction. The principle is not Fleming's right-hand rule. You use Fleming's right-hand rule to determine the direction of the induced current if the direction of the applied force is given to you. And remember, AC generator, the crucial part is slip rings. For a DC generator, it is split rings. So please distinguish between those two. And then mechanical energy to electrical energy, that is what Eskom is doing for us with their steam generators. Right, then remember an AC circuit, the voltage time graph, it is a sine graph. And you must also be able to relate the maximum position on your graph to the position of the coil. Remember, the maximum position of the Vmax value correlates to your coil be in the parallel position, where the maximum voltage is induced. If it's in the vertical, then it's on the zero voltage that is induced. Electrical motor, please. The principle is a motor effect, and you use Fleming's left-hand rule to determine the direction of the motion. And remember, the split ring is a crucial part in this electric motor. Therefore, for a motor, electrical motor, and an DC generator can look the same because they both have split ring commutators. But for a motor, there will be a battery in the circuit. And for a DC generator, there will be no battery in the circuit. Maybe you can distinguish in that way. That concludes our electrodynamics. And next we are moving on to the photoelectric effect. And quickly indicating a few important issues here. Again, remember your definitions. The important part in the photoelectric effect definition is that as electrons are emitted from a surface. You don't have to say metal surface. The crucial part is the word surface when light is incident on it. Threshold frequency, remember the minimum frequency, and work function, the minimum energy. Don't confuse the two definitions. Now, the formula for photoelectric effect, please understand each component, that E is equal to HF, that's the energy of the photon. The work function, that is the energy HFO, that's the energy needed to remove the electron from the metal surface. And then EK max. Remember, the subscript max must be there. You're going to lose a mark if you omit the subscript max. So understand this formula, please. Study your data. Remember, at photoelectric effect, also the formula C equals lambda times F is also a formula that you can use, for instance, to calculate the frequency of a photon if they give you the wavelength. Sometimes they also give you an energy diagram. So the energy of the photon is calculated in by this emission process, where electron drops from a higher to a lower energy level, and the difference between the two energy levels is equal to the energy of the photon. Now, again, and lastly on this, again, the last few papers, they've used a graph, interpretation of a graph for photoelectric effect. And again, it's a level 4 question, and again, you must be able to derive the values from this graph. Firstly, you will see that we can derive HFO. That frequency where the graph starts is a threshold frequency. So you can F0, so you can calculate the work function. Secondly, you can also get the energy of the photon. They are relating to E1. So on the graph, you can go downwards to get the frequency of the photon with an energy E1. And then important, you must again relate it to Y equals mx plus c, to a straight line graph. Again, this indicates kinetic energy is directly proportional to frequency. There's the key. Then you must change it to an equation. So you must get a gradient. In this instance, what relates to the frequency? Planck's constant. So this is an indication that the gradient is equal to Planck's constant. And then you have, if you extrapolate this graph, you will get a negative value on the energy graph, and that y-intersect with a negative value indicates to the work function that the value of the work function. So at the end, after you have for the relationship between kinetic energy and frequency, you must be sure that it includes all the components of the Doppler equation. The energy of the photon, the work function, and the maximum kinetic energy. Right. We're drawing to a conclusion. Now, lastly, kinetic energy of the photon. Remember, intensity don't increases the kinetic energy of a photon. No influence. It's only if the frequency of the photon is increased, then the energy of the photon increases. Intensity only increases the number of photoelectrons emitted. It's only an increase in frequency. And then, lastly, on photoelectric effects, there are two kind of spectrums. Emission spectrum, when you radiate, when you put a gas, hydrogen gas, under a big voltage, and you give energy to the gas, and then it emits electrons, emits photons. When electrons drop down from a higher to a lower energy level, it emits photons, and then you get a line spectrum, emission spectrum with the lines relating to the energy and the color. Then the second type of spectrum that you must remember, please, is the absorption spectrum, and then that is where you shine light through a cold gas, and then some frequencies of light are absorbed. Right. Now, just quickly on multiple choice questions, please remember, you must at least spend 20 to 25 minutes on it. Leave those that you are not sure about. Use a highlighter, a pencil to highlight key values. Try to relate a definition or a formula to that question, and then at last, when you're totally unsure, eliminate the two modes between two distractors. Right, in my time left, I'm just maybe try to conclude maybe something about Newton's laws, and that will be only in the last 2 minutes left. I'm going to try to relate something to you about Newton's second law. Sorry, I'm just moving on here. Right, when discussing Newton's laws, it's very important that you know there's a lot of definitions that can be asked. And Newton's first law, second law, third law, one of those are going to be asked. So make sure that you know it all. And then there's also definitions on a frictional force, definitions on what a normal force is. The previous time, the learners really messed up with the definitions on a normal force. So make sure that you realize that you really know the definition on normal force and don't mess up with it. Then, lastly, with Newton's calculations on Newton's second law, please always start off with F net equals ma before you start substituting the different forces into that formula. Start off with F net ma for both objects. Draw force diagrams for both objects. Even if they don't ask it, you must make sure that you include all forces when working with F net equals ma. And remember that A is the system's acceleration. It is can't be a value for gravitational accelerations. Don't use a system approach. Please, don't eliminate tension. Have two different vector equations for each object and then solve by means of simultaneous equations. Right, I think I'm going to conclude at this stage with Newton's second law. I just want to maybe laugh in Newton's gravitational law and even with kinetic energy, half mv squared. Learners many a times forget. They write down the correct formula, say for instance, half mv final squared, but they don't square the value for v and really lose 2 marks for a wrong substitution and for a wrong answer. So I know you are under pressure, and therefore, just read properly through your questions, highlight, write down your data, make sure you select the most suited formula, and then if you have time, just go carefully, quickly through your paper, looking at not omitting units, not omitting a direction where needed, and then make sure that you don't lose unnecessary marks that you're not supposed to lose. All of the best for Friday. Really take it as a challenge, and I hope you will leave the exam hall with a positive mindset after writing the physics paper. Thank you very much. Okay, at the end, okay. Sorry, I forgot that something. Remember, you stand a chance to win an MTN bucket hat as well as a T-shirt. If you go to the Free State Department of Education Facebook page and then answer the following question. Now, my question I pose to you that you must answer for that prize answer correctly is, my question is, what is the influence on the total resistance and the total current in the electric circuit if the circuit experiences a short circuit? What happens to the total resistance and the total current if a circuit experiences a short circuit? And if you give the correct answer, you have a chance to win that prizes. All of the best. Thank you. Sorry.